Okay, today we're going to be solving systems of inequalities. So it's very similar to when we graphed linear inequalities and we have to shade. You're just going to have to figure out where I'm shading. Is that shading for... Your answer is going to be where you shade twice, okay? And I'll highlight that with our first example. Okay, solving the system by graphing. Okay, so the first one I'm going to do in blue. So 2x plus 2. Plus 2, slope of 2. I'm going to zoom out. It's dashed. That's what I was trying to check. So now I test 0, 0. 0 less than or equal to 2 times 0 plus 2. 0 less than or equal to 2. That's true. So that's where I would shade for that one. I'm going to do the other one in red. Negative x minus 3. Okay, so minus 3, 1, 2, 3, and it's a negative sloping line, so I'm going to do down and right 1, up, left 1. I remembered it was equal to. I should have gone back and just double checked. Okay. So I can test 0, 0 in that equation. Zero is greater than or equal to negative 3. That's true. So I'm shading above for that equation. Now your answer is where you've shaded twice. So I'm going to shade that in purple since blue and red make purple. Okay, so your answer is all of that area there. Okay, so it's where you've shaded twice. Okay, let's graph both of these. So I have this equation. I'm going to subtract the 2x over. Okay, y is greater than negative 2x plus 4. So, plus 4, negative slope of 2, was that equal to? It was equal to. Okay. Okay, so I'm going to do this one a little bit differently. So if I test the point 0, 0, I'm going to test it in this one that I've manipulated. 0 greater than or equal to 4. So that's false. So I'm going to be shading this way. Kind of draw maybe little arrows, or just keep in mind that I'm shading that way. Now the other one, I am going to subtract the x over. I'm going to divide by 2. So now negative 1/2 x minus 2. Negative 1/2 x minus 2. Down 1, right 2, down 1, right 2, up 1, left 2, up 1, left 2. And this was dashed. And then I test 0, 0. So 0 greater than -2. That is true. So I would be shading above for this. Now, where are your arrows going both? Your arrows for both are all of these points here. So all of these points, what you're shading is your solution to your system of equations. So all of this is your solution to your system of equations. Okay. Okay. I'll do green for this one. Sure. Why not? So this first one, -3x plus 1. Plus 1. -3. So I go down 3. Right 1. Down 3. Right 1. Up 3. 1, 2, 3. Left 1. Up 3. Left 1. And was I equal to? I was, so I don't have to worry about a dashed line. I'm a solid line. Okay, so I'm going to test 0, 0, 0 greater than or equal to, if I plug in 0 there, that term goes away. 0 is not greater than 1, so I would be shading this way. Let's do another color. What fun color do I want to use? I'll make sure they don't clash. We'll do blue. -3x minus 2. So minus 2. -3. Down 1, 2, 3 over 1. 2, 3. So again, we test 0, 0. So 0 less than or equal to -2. 0 is less than or equal to -2. That is definitely not true because 0 is greater than it. So I would shade this way. So I'm shading this way for my blue. I'm shading that way for my green. I didn't shade anything in common. So what's my answer here? No solution. There are no points that I've shaded that are common to both. So that's my answer. Okay, that is my video on graphing linear inequalities.